Here we are again with a question from JE Advanced 2018. Basically, we are given an integral equation and we have to solve the given equation for f of x. So let us do that. So before going through the solution, I would recommend all of you to pause the video and give this question a try. So this is a good question. Let us solve this. So this is the functional equation. This is the integral equation that is given to us. And the trick to solve these kind of questions is to differentiate the given integral equation on both sides, especially when you have a variable x or a function of x involved as an upper limit of the integral. So before proceeding with the question, so I would like to state one rule. This is Leibniz rule. Let us say you have an integral whose lower limit is a function of x, a of x, and upper limit is also a function of x, that is b of x, and the integrand is a function of t. If you have to differentiate this integral, you can use this formula. First, substitute the upper limit in place of t and take the derivative of upper limit with respect to x minus substitute the lower limit in place of t and take the derivative of lower limit with respect to x. So this is Leibniz rule and it is used to differentiate an integral. So now let us go back to the equation. So f of x is equals to 1 minus 2x plus integral 0 to x e to the power x minus t f of t dt. So this is f of x is equals to 1 minus 2x. Here e power x is a constant because the integration is done over the variable t. Here the variable is t. So x is a constant. So e to the power x can be brought outside. So f of t dt. And now the integral is a function of t and the limits of the integral are the functions of x. So we can apply Leibniz rule here. So let us go ahead and differentiate this integral equation on both sides. So left hand side will be f dash of x, that is equals to differentiation of 1 is 0, differentiation of minus 2x is minus 2 plus, so this is a function of x and this is a function of x. So this whole integral is a function of x. So we have to apply the product rule of differentiation here. So e power x, let us put that as it is, and we have to differentiate the integral 0 to x e to the power minus t f of t dt. Now next we will put the integral as it is and we will differentiate e to the power x. And the differentiation is also e to the power x. Now f dash x is equals to minus 2 plus e to the power x. So according to Leibniz rule, if we differentiate this integral, so we will get substitute the upper limit in place of t, e to the power minus x into f of x, and take the derivative of upper limit, that is 1, minus put the lower limit in place of t and take the derivative of lower limit, that is 0, plus e to the power x. This integral can be, if we go back to this equation, this integral can be written as f of x minus 1 plus 2x by e to the power x. So this and this gets cancelled. So f dash of x is equals to minus 2 plus e to the, so this term is 0. So e to the power x into e to the power minus x is 1. So this is f of x plus f of x minus 1 plus 2x. So f dash of x minus 2f of x is equals to 2x minus 3. So we have a differential equation here. So to solve the differential equation, let us find the integrating factor. Integrating factor is e to the power integral minus 2, that is coefficient of f of x dx. So that is e to the power minus 2x. Multiply this equation with e to the power minus 2x. E to the power minus 2x into f dash of x minus 2 e to the power minus 2x into f of x is equals to e to the power minus 2x into 2x minus 3 into e to the power minus 2x. Integrate on both. So this is d by dx of f of x into e to the power minus 2x. So this will come as it is. Integrate on both sides. Dx. So this will be e to the power minus 2x into f of x is equals to twice of integral x into e to the power minus 2x minus 3 times of integral e to the power minus 2x. So let us find out this integral. X into e to the power minus 2x. So you have two functions in x and you have to integrate them. So this will be u x into e to the power minus 2x by minus 2. So basically the integration of e to the power minus 2x minus integral of e to the power minus 2x by minus 2 into dx. So this is x into e to the power minus 2x by 2 plus half into e to the power minus 2x by minus 2. So let us go back to this equation. So e to the power minus 2x f of x is equals to 2 into minus x e to the power minus 2x by 2 minus e to the power minus 2x by 4 minus 3 into the integral of e to the power minus 2x is e to the power minus 2x by minus 2 plus some constant c. So that is e to the power minus 2x f of x is equals to minus x e to the power minus 2x minus half e to the power minus 2x plus 3 by 2 e to the power minus 2x plus c. So multiply both sides with e to the power plus 2x. So this will be f of x. This is minus x. This is minus half. This is plus 3 by 2 plus c into e to the power 2x. So that is f of x is equals to minus x plus 1 plus c into e to the power 2x. So now we got f of x. Now the job is to find the value of c. So let us go back to the question. This is the equation we got, right? So put x equal to 0 in this equation. F of 0 is equal to 1 minus 2 times of 0 is 0 plus e to the power x, and if we put this x is equal to 0, the upper and lower limits of the integral are 0. So the area will be 0. So this will be 0. So f of 0 is equals to 1. So put x equal to 0 here. F of 0 is equals to minus 0 plus 1 plus c into e power 0 is 1. So f of 0 is 1. 1 is equals to 1 plus c. So c is equals to 0. Therefore, f of x is equals to 1 minus x. We found out f of x. Now option A is the curve y equal to f of x passes through 1 comma 2. Option B is 2 comma minus 1. 1 comma 2, 2 comma minus 1. So if you put x is equals to 1, f of x is equal to 0. Put x is equals to 2, f of x is equals to minus 1. So option A is incorrect. Option B is correct. Let us go to option C. The area of the region x comma y belongs to 0, 1 close brackets f of x less than or equals to y less than or equals to root of 1 minus x square. F of x less than or equals to y less than or equals to root of 1 minus x square. We have to find out this area. F of x is 1 minus x less than or equals to y less than or equals to root of 1 minus x square. So let us draw the graph. So y is equals to, first we have to draw y is equals to 1 minus x. First let's draw the graph of this. When y is equal to 0, x is equals to 1. When x is equal to 0, y is equals to 1. So this is a straight line passing through these 2 points. So y less than or equals to, y greater than or equal to 1 minus x. And let us draw the graph of this. Y less than or equals to root 1 minus x square. This is basically a circle. So y square less than or equal to 1 minus x square plus y square less than or equal to 1. So this is basically a circle of unit radius. Since they did not use plus or minus root 1 minus x square, so we are considering only the upper portion, upper semicircle. So y should be greater than this line and less than this circle. So this is the area that we have to find out. So to find out that area, first we will find out the area of this quarter circle. First we will find out the area of this quarter circle. Then we will subtract that area from the area of this triangle. So area of quarter circle is 1 by 4 pi r square minus area of this triangle half base into height, because it is a right angle triangle. Base is 1, height is 1. So 1 by 4 pi r, radius is 1. So pi minus 1 by 2. So that is pi minus 2 by 4. This is the area of the required region. So pi minus 2 by 4. Option C is correct. Option C is correct. Option D is incorrect. So answer is B and C. So the mistake that, like, the thing that can go wrong in this question is here. If you do not take out e to the power x outside the integral and apply the Leibniz rule, then it will completely go wrong, because the Leibniz rule can only be applied when the entire integrand is in terms of t. You should not apply the Leibniz rule here. So that is the only thing that can go wrong in this problem. So yeah.